Got sent this video recently by a friend. It's called Non-Invasive Assessment of Spinal Function by Dr. Gracovetsky, who's from Canada, might I add. I won't speak to all of the video's content, but what really caught my interest most was the example of how someone who, though lacking arms and legs, generated a gait cycle very effectively. In this video, Dr. Gracovetsky argues that the gait cycle is generated by the spine first, and the arms and legs assist in that existing process. As well, he argues that it's not actually a hard comparison to make because sea creatures, fish, do the same thing but in a different plane. Limbs will add range, rapid adaptation to the ground, and a control of the terrain, but are not the complete creators of gait. One edit or clarification I feel necessary to make is that when it is said it is the spine that generates or is the engine for gait, I'm fairly certain they mean, or at least they really should, that it's the spine and closely related areas, inclusive of the soft tissues and the nervous system. You'll notice that many of the mechanics we explain in this person's gait are exaggerated relative to what a person with full limbs would do. And this is not a problem at all, it's a benefit. To start, here the ischiae have become the support and pivot points to generate the turns of the pelvis that propel the body forward against the ground. You can see the pelvis spinning on the right side here, but for that to happen, the opposite ischia, the left, has to be pulled upward to clear the ground. To allow for the relatively static pelvis to come up on the one side, something has to bend. The next most bendable thing attached is the lumbar spine. And even though L1 to 4 only side bends maybe 5 degrees, there is a bit more bend at L5. So the lumbar spine will bend to the left just a bit to lift the left ischia. As it's being pulled up, it should also be pulled forward. Therefore, any muscles oriented in one or both of these directions should be contracting. In this case, it's the erector spinae, quadratus lumborum, aka QL, and obliques. The QL and obliques actually come together nicely on the sides of the body, pulling the pelvis circumferentially. If the left is shortening, the right by comparison is lengthening. And much like the left, to do this without breaking something, we have to have a bend somewhere, which is most likely occurring at T10 to 12-ish to the left. Going back to our left side of the pelvis, for those muscles that pull up on the pelvis, it means that their upper attachment is also secure and stable enough to bear that weight. To do that, the thorax has shifted, or what's called translated, to the right. The forward motion of the pelvis must be reinforced or pulled along in much the same way. This comes from the thorax again, but also the upper girdle, what we typically call the arm swing. Now here's something. Just because something is floating or considered more mobile doesn't mean it can't be a fixed point or pull on something else. If this half of the upper girdle is traveling backwards and it has momentum, it has weight to it. Weight enough to create stretch and weight enough to pull another attached thing forward, even just a little. If we connect a line along the front, such as the psoas to spine and obliques to ribs, this is of course inclusive of the fascial sheaths in the same regions, then the pec muscles to scapula and arm. Starting back at the beginning, the ischia and opposite shoulder are both posterior, both pulled back, meaning that this path is stretched to somewhat of a limit, and now the right shoulder moving backwards can pull forwards on the left pelvis. As well, because stretched muscle wants to shorten automatically along with the natural recoil of the fascia, this results in the active forward pull of the left side of the pelvis. This is a connective tissue function of storing and releasing energy we talk about, usually in regards to the foot, but it actually happens all over the body. To drive the point home, notice how the gait is exaggerated in both force applied to traveling through the transverse plane and abduction of the arm to increase stretch, each of these occurring to compensate for decreased leverage. Which for us is actually awesome because it makes it so that the trunk mechanics of the gait cycle and their importance are that much more apparent and obvious. Of course, this entire description has only been half of the gait cycle, and once this side is finished, it's already initiating the next phase.